Okay, thank you, everybody. I'm going to get started again. It's my pleasure to introduce the trustee of the Saylor Foundation, Michael Saylor. For his day job, he actually runs a very large company called MicroStrategy. He's the chairman and CEO. They're a global enterprise leader in enterprise analytics and mobility software. They have over 2,000 employees worldwide. Since we're changing up the program a little short on time, Michael's full bio is in your program, but you'll note he's a graduate of MIT with 2 degrees, both earned on a full ROTC scholarship, and upon graduation he was commissioned as a second lieutenant in the United States Air Force. When I've heard him speak, Michael often cites his ROTC scholarship as inspiration for his willingness and the passion for paying it forward and finding a way to help others get a first-class education without having to take a lot of debt in order to do so. His philanthropy extends to many areas, but his commitment to education is extraordinary, giving not just his resources, but his time and his energy for new ideas as well. So with that, please join me in welcoming Michael Saylor. Thank you.
I want to thank everybody for being here today, and thanks for the time and commitment you've given to open education. As I know, everybody's got their own passions, but it's so exciting to see everybody coming together at this event. I know to a certain extent I'll be preaching to the choir, but Jeff asked me to share a few thoughts on my observations about technology trends in the marketplace and the views of various employers in the tech business toward education and toward open education. And as I have observed, things are changing very rapidly this year. In fact, they're changing rapidly every quarter. It seems like for the past 3 or 4 years, the pace of change has accelerated, and of course it's been accelerating for quite a while. Every day I get up and I see a new and interesting thing that is just another brick in the architecture of open education. So I thought I'd share a few observations with you. For those of you who know, I wrote a book called The Mobile Wave in 2012, and one of the themes of the book was the dematerialization of products and services from the physical world into the cyber world. So many things that used to be a product, like a camera, like a printer, now like a typewriter, right? Now they're actually software applications or icons on your iPhone. And oftentimes, as they dematerialize, they became not just pieces of software, but they became entire software networks. So something like the Rand McNally Atlas, which once was a product that we printed, eventually became Google Maps, but then Google Maps went from dematerialization of the Atlas to 200,000 pages of satellite images, which you never could add in an Atlas. And then it went to real-time traffic, and then it went to an intelligent advisor telling you how to drive to work. And so what started as a physical product in the real world became an intelligence service, which is software running on a network with hundreds of billions of lines of telemetry, and we never go back. Now that's a really interesting trend, this dematerialization, and the world continues to digitize at a more rapid rate. Why is that important? Because in a world of physical things, if I have a wind tunnel and I want to teach someone how to build an airplane, I need to produce the wind tunnel, and there's a physical limit to the number of people that can fit into the wind tunnel and use the facility. As an undergraduate at MIT, we didn't get to use the wind tunnel. It was too expensive. Now, in the world where you create a cyber wind tunnel, you can produce 1 million copies of the wind tunnel and give it away to people in 100,000 places. And as the cost of hardware gets cheaper and the cost of RAM gets cheaper, and RAM's 10,000 times cheaper than it was 15 years ago, computers are 1,000 to 10,000 times more powerful than they were 20 years ago. The advent of things like AWS have resulted in a world where we have software. You can punch a button at 9 a.m. and at 9:23 a.m. you can spin up a dedicated environment to support 87,000 users in Singapore, and you can run it for the next 4 hours and turn it off. Now, 4 years ago, that would have cost you 150 full-time employees and $30 million of capital. Today, you could do it in 37 minutes. And the significance is as we get to that world where you've got infinite capacity on the iPad and infinite capacity on the laptop and massive capacity in the back-end servers, as everything gets 10,000 times cheaper, better, faster, and as we digitize, we're able to move from a world of fragile to a world of agile. In the fragile world, you wanted to try something, it cost you $40 million in 4 years, and if you screwed it up, you're out 4 years and you're out $40 million. In the agile world, you wanted to try it, you tried it in 4 hours, or in 40 hours, you spent no capital, and if you screwed it up, you throw it away and you try something else, right? And if I can try 150 things fast, then I don't have to be perfect, I just have to find one out of 150 things that works. I discard the other 149 things, civilization advances. In the world of the wind tunnel, you can't, right? Things that have physical capital involved and bricks and mortar involved, they're just inherently more fragile. It's going to be much harder for us to do things. And one thing that's fragile and expensive is a traditional education and at a bricks and mortar institution in a traditional fashion. It takes too long, it costs too much money. This digitization, digital revolution, we were big on it in the year 2000, but there's a better story every single year that goes by. I was sitting with a friend of mine the other day, very successful DC businessman, and he just took on a job running a drone company. And I said, what do you do? He said, well, we've got these drones. I said, drones like the ones that fly around and take like a photo? He said, well, no, our drones are flying LiDAR arrays. What is LiDAR? Anybody know what LiDAR is? Anybody heard of it? You're advanced, right? Light detection and ranging. It's the technology that lets cars drive, self-drive, but what it means is I put this array on the bottom of a drone and it flashes the room and it takes a perfect image of everything. You put it on a drone above a beach, it'll tell you everything. What is everything? It means you now have data that'll tell you where the sharks are. You can put it over agriculture. I can tell you where all the plants are, what's living, what's dying, how fast it's growing, is it safe, is it not safe, count the number of cats running through the field. Now, why is it interesting? Well, because it's like 1,000,000 times more data than a photo. Like, we think, oh, digital photos, that's a lot. Well, this LiDAR thing is this array, and now we've got these drones that are $1,000 flying around doing this array that are collecting. We're not talking about gigabytes or terabytes of data anymore. I don't even, exabytes a minute of data. And it's a business that didn't exist 2 years ago. And he goes, yeah, well, I had someone that wanted an insurance company wanted to hire me to fly over every single roof, whatever in the country or something, and figure out, what's dangerous or not. Now, why is that interesting? Well, in every single field, there's something like that that's driving the digital revolution. And the world that was physical is digitizing. And that means all of the skills and all of the goods and services that were physical are on this path to digitizing. And whereas it used to be, I had to put you in a lab and hand you some tools to learn to do something or to prove you had the capability to do something, now I can fly a drone over a beach, I can hand the data to a programmer, and the programmer can write algorithms to spot sharks. And you don't have to fly in a plane, and you don't have to be on the beach. You just simply need to have a set of skills, right? And what are they, right? Math, science, engineering, coding, a whole set of technical skills. And every single industry that rolls over to become digitized creates a ton of jobs for people that actually have these kind of STEM skills and techniques. Now, why is that interesting? Well, because in a world of digital, the machine is now software. Software is an information machine, and there are more and more information machines that we need to build. We don't have enough people to build them. you know, there's a tendency to think, well, we're going linearly, we used to do that, and we're doing this. But in fact, my observation in my industry is we're in an expanding universe, and it's expanding, it's an expanding universe of expectations, of demands, of requirements, of aspirations. Everybody wants more of everything in every direction, right? It's like Elon Musk wants to go to Mars, and now people don't laugh at that. They're like, they're wanting to do it. We want to cure every cancer, and people don't laugh. It used to be people wanted to make you comfortable. Now people think you can cure the cancer, right? We want to get rid of sharks on the beach. We want everything to run perfectly. There is no tolerance for imperfection. I say in my industry, we used to like build software running on top of 3 databases. Oracle, SQL Server, Teradata, something. Now they want to run software on top of 48 different relational databases, 10 different OLAP databases, 50 different big data databases, 100 different enterprise applications simultaneously, and also splice in Wikipedia, Google, you know, Facebook, Twitter, everything else. So you go to the customer, you say, well, which of these new things do you want to do? They're like, well, I just want to do 187 things simultaneously. Okay, and we used to deploy it to DOS, and then there was Windows. Do you want to know Windows? No, then it's the web. Okay, so you're going from Windows to web. No, we want Windows and the web. What's new? Well, now we want it Windows and the web and iOS. So do you want to go from Windows to iOS? No, I want iOS and Windows and Android. And I want it to run on all these clients, and I want it to run on smartphones. Smartphones instead of MacBooks? No, smartphones and MacBooks. I want it to run on every client, and you want it to run no, I want it to run everywhere. Well, everywhere? Everywhere. Well, everywhere means I have to, well, you have to comply with Chinese privacy policies in Beijing, but it's different in Singapore, and that's different in Germany, which is different in Ireland, which is different in Brazil, which is different in the US, which is probably different in California of the US. So everything it's an expanding universe in every direction. And we got 1 million problems. And every one of them, you know, how do you find sharks from LiDAR, right? You know, that's a problem. We got 1 million problems, and it's pretty clear in the tech world, you want to solve the problem, you need to have mastered all of the undergraduate skills, and then probably a bunch of master skills. And the definition of a PhD, or the classical definition is you know, someone who is capable of contributing, making a unique seminal contribution to the body of knowledge of the civilization. If you're able to make a unique contribution, then you probably deserve a doctorate. If you're able to do algebra, you probably don't deserve a doctorate. We have about 10 million PhDs the last time I checked. 5 million in the US, 5 million everywhere else. There's like 7 or 8 billion people on the planet. If you think about it a bit, and you think about what skills are required to, you know, put chips underneath the skin that, you know, solve diabetes or cure cancer or do whatever, you come to the conclusion you probably need 1 billion PhDs. There's probably, we don't need 7 billion, but we need more than 10 million. You probably need like 1 billion people on the planet that are able to make a unique contribution. Because if you want to create an airplane that flies 15,000 miles or turn it into a rocket ship, you're not going to do it with algebra. You know, you're not going to do it without having mastered postgraduate thermodynamics and coding and probably plugged into someone's network. And we desperately need more sources of new engines, new propulsion, new breakthroughs in medicine, new breakthroughs everywhere. And that'll be done with a lot of very sophisticated, educated people, human capital. We don't have enough human capital, right? I mean, the cost to create a PhD is $1 million a year. $1 million total. It's like, it's just expensive, right? If it's $250,000 to get through college, it's $250,000 to get K through 12, it's another $250,000 for the rest. Maybe someone can figure out how to do it for $200,000, but $200,000 to $1 million to take a person and convert them into a PhD. If you do it the traditional way, and so I don't think we can do it the traditional way. I mean, the only way we're going to create the kind of human capital we need to solve all of these problems and move the civilization forward is if we provide 100x more education. Like even if even if I said I got $100 billion and I'll pay everybody's education everywhere on the planet, we still don't have the capacity in the bricks and mortar institutions to train these people, right? So if I paid everybody's Harvard education, Harvard still will cap you at whatever the number of students is they want on the campus. So we need 100x more capacity, and we need a 100x cheaper price, right? The cost per education unit delivered's got to go way down. The capacity's got to go way up. To do that, you need to create a machine, and in this case, a machine to manufacture education. And software that teaches is that machine. And we know that you can create software that will teach people. Now, we also know, if I want to teach a ballet, right, if I'm working in a skill like golf or ballet or cooking, right? You're in the physical world, in the analog world, and all of a sudden you're dealing with fragility and capital intensity. It's really hard to do that with a piece of software, right? So I don't think we're going to solve the problem of how do you create great cheap education in the physical world so easily. We will struggle with that. But on the other hand, if what I wanted to do was generate someone that knows calculus, in theory, there's no reason why you can't learn calculus in front of a computer just as well as learning calculus in a classroom. And as a practical matter, and I get a kick out of this, on Saylor.org, we have lectures from MIT that were uploaded from the time that I was at MIT, okay? But here's the joke, right? When I was at MIT, my entire family savings for the last 200 years would have been slurped up by the first 6 weeks of my education there as a student, right? It was too expensive. And I sat in a room bigger than this where the lecturer was as far away as you are, my dear, in the back, right? And I squinted to figure out what was going on the chalkboard. It was very uncomfortable. Today, you would get a better education for nothing with a $500 computer logging into Saylor.org. And I know because I was there, right? I lived it. So just because something is expensive, it doesn't mean it's better. The world is full of products that are manufactured, the iPhone, for example, and there's nobody that thinks that if they spent $100,000 and built their own phone, it would be better than the one that they got from Apple. And if you spent $100 million to build your own phone, it still wouldn't be better from the one you got from Apple. So productizing education, I think, is critical for us. And I am optimistic because it's a lot easier to productize the teaching of algebra or calculus or coding. You can objectively determine that someone knows 2 + 2 = 4. You don't need the opinion of someone that smelled them in the classroom. They don't need to show up and sit in the front row on time. All they need to do is prove that 2 + 2 = 4. And that hasn't changed for thousands and thousands of years, so one would think that you could automate it and slip the copyright by now. I think open education plus computer power plus cheap, ubiquitous networks, right? They lead to better, cheaper, more comprehensive education, right? That's the magic there. Now, if you look at it from an employer point of view, I think employers are becoming much more data-driven today. And I mean, that's a buzzword, so let me tell you what I mean by that. We've been in business 27 years. I've hired, I don't know, 20,000 people over the course of 27 years. In the year 2016, for the first time, we started to administer diagnostics. And we used a platform called eSkill and HackerRank. And we use a product called Smart Recruiters to recruit the people. So here's how it works. For every single person that goes to an interview with our company, and this means the last 5,000 people, we probably hired 1,000, so probably 1,000 people have been hired in this technique. Everybody goes to the company, we give them an A, B, C, D, E diagnostic. A, analytics. It's like the math version of the SAT. It takes about 20 minutes to 30 minutes, and we figure out what your symbolic reasoning is. B, business. We actually give people a business exam to figure out if they have common sense reflexes about how to do business in the enterprise. Like, you have a meeting, how early should you show up for the meeting? 5 minutes before? 15 minutes before? Etc. A lot of standard business tests, just questions to see if someone has common sense. C, coding. Can they code? And we used HackerRank to see if they could code. It's a quick evaluation. D, design. We actually give people about 25 different systems. We say, here's some information. Here are 5 different ways to present the information. Pick the best way. And you know what? Like, I can administer that in half an hour, and I can tell in 1 second, I can tell whether someone has the aptitude, the talent to be able to design and create application interfaces. And that's more important to me than knowing that they have a degree in fine arts from Harvard, right? And in fact, the last one, by the way, was English, E. But we also have an F for French, a G for German, and M is for Mandarin, right? And we check some other languages. But the general idea is, let's just figure out, do they have these basic aptitudes? And it's like the SAT, but you know what? It used to be, people would say, well, the SAT, that's no longer relevant, and you've been out of in the workforce for 15 years, and so we won't look at that. We'll just do a bunch of interviews, and we'll look at your resume. And we have a lot of things we take into account when we hire someone. We do look at their resume, we do interview them, but we actually found that a better strategy is we put the diagnostics up front, we screen, and then we interview, then we look at the resume. I could tell you, you could have a master's degree in computer science from Harvard or from MIT, you get a 50 on the HackerRank, and then I have to compare you to someone from a university in China I never met before in my life who's 8,000 miles away, I will never meet, and in 1 second they're 98, I will hire them. Right? And so it's a very interesting thing. We're lurching from a subjective, traditional set of credentials to objective, universal set of credentials. And by the way, these aren't perfect, but I'll tell you what's interesting here is we applied them, and we found that the leading indicator of failure of all executives in the company is a low analytics score. Like if they rated below 50, and it's 0 to 100, by the way, and if you come out of school and you're a bright whippersnapper, you're going to be 90 to 100, and then over time those skills kind of start to languish a little bit, and they'll fade, and 25 years out maybe you'll be 80 instead of 100, but you'll still be 80. And if 25 years out you're 50 or 40 or 30 or 20 or whatever the number is, we found that those people come into the company, they just don't understand what's going on, or they can't communicate fast enough, they can't learn fast enough, so they fail at their job, or they get frustrated, or people get frustrated with them, and they get pushed out. And in the last, say I have 20 executives I hire, 10 of them fail, and all 10 of them, had diagnostic scores which were really low, and we looked past it to the resume and to the credential. Everybody's got good credentials. By the way, they all got a lot of experience. And so the problem with experience is if you're really bad at your job, you end up having a lot of experience in a lot of different places. Yeah. So that's really difficult. And there's an interview bias, which is, I meet with someone, we all like the people we meet with because it's a human nature thing to like them. But there's a phrase in aviation. I learned to fly when I was in the Air Force. It's like, trust your instruments. Don't trust what your brain's telling you. Trust your instruments, because your brain's going to kill you. The instrument tells you that you're upside down, right? Pay attention to the horizon instrumentation. The same is true in our business. We're recruiting so fast that we're better off to trust our instrumentation. Now, of course, we're always tuning it, and these aren't perfect diagnostics, so we augment them with capability assessments once people join, and performance assessments. I'll tell you, fascinating with performance assessment, we used to take one assessment per year. Your boss gives you a rating once a year. And then we said, well, how about once a quarter? Your boss gives you a rating once a quarter. And then we thought, well, wouldn't it be good to see what the rest of the people on your team think? So then we roll out 360 degree, where we ask all the people that work for you, whether or not they find the engagement constructive. And what about all your peers and your counterparties? Do they find it, or what we'll call collaborators? Do they find it constructive? And then what about the 2 or 3 superiors? Did they find it constructive? Now, for 2,000 people, instead of 2,000 data points a year, I end up with 2,000 data points times 10, or 20,000 data points a quarter, 80,000 a year. Okay, and if you come into the company and you're just driving everybody crazy, it's not going to matter what your academic credentials were, right? Maybe you have a degree in how to get along with people from Harvard, but then everybody hates you, right? Well, so we now have data that tells us, we don't have to guess, we don't have to take everybody else's word for it. We take this to the extreme. There's engagement analytics now where we actually start to get ratings. Every time you teach a class, we ask every student whether they enjoyed it. Like we would ask every one of you whether you enjoyed my speech or didn't enjoy my speech. Every time we have a meeting, we ask people whether they thought the meeting was constructive. There's this concept that Ray Dalio has called radical transparency. What if we rate every single meeting? You have 200 meetings a year and everybody finds they get a lot from each one of them, or you have 200 meetings a year and you were doing great in January and February, and in March all your meetings went negative. Now, it's a very interesting world, but here's my point. In a world where we didn't collect the data and we couldn't manipulate the data, we had to rely upon traditional credentials that came from politically established institutions, right? And my best bet is I get someone with a master's degree in computer science from MIT. That's the old world. That's a fragile world, and it's a fragile world because MIT only produces a few hundred of those things every single year, and that cuts out 7 billion people who just don't have a chance. The new world is we put in place a more objective set of diagnostics, and I would love, right, for someone to put out like a branded thermodynamics diagnostic where they tell me this person certainly knows thermodynamics as of yesterday. I know thermodynamics as of when I was at MIT, but I can tell you right now, you wouldn't want to trust your life to my thermodynamic calculations because I forgot. Okay? So how do you actually figure out in 5 seconds that someone didn't forget? Now, it might take the applicant half an hour or an hour or whatever, but it only takes the employer a second. And this is the important point, because we want to sift through 18,000 people in 30 seconds. Like there are massive pools of capital right now controlled by executives who are trying to solve a big problem in the market or pursue an opportunity in the market. Now, I am a little executive with a little pool of capital, but to put this in perspective, I would hire 100 people like in 30 seconds if you gave me that a certain objective capability that I want. And I would hire them in Warsaw or in China or in some place I've never been. I'm not going to go. But I could instantly create 100 jobs. I could probably create 100 jobs, 200-300 jobs, with nothing more than a few numbers. What we need is liquid competence information. And it is forming, right? Hence the rise of eSkill, and hence the rise of HackerRank and the like. And when you consider the Googles of the world and the Amazons of the world, they will hire 1 million people in a heartbeat if they actually can get that kind of objective talent. So the trend is going to continue to capture this mega amount of data, and as the data forms and the world digitizes, the skills that are economically feasible are manipulating that data with these information machines. Those skills you can test. Like there's a big data set from Uber. They'll just send you the data set. Okay, you've got the data set, fix traffic. Okay, 1 million people can take the data set, and it's like they're owning the traffic network of the United States. Fix the traffic. What do you need? It used to be you needed a country to fix the traffic, and you needed to be able to experiment on the country. Today, maybe you might not need more than a $1,000 computer to fix the traffic, and maybe Maybe 19,000 people will try, but 100 will succeed, and they'll be really good. So our ability to find the talent is much greater. Our need to find it is greater. These approaches to finding talent, they're all about agile, and agile is all about speed, and speed is life. And if I can do things fast, and I can do them everywhere, you can see a world where we want to trade more. We want to tap into labor pools everywhere in China and India, wherever the labor might be. We want to create the talent, and then we want to repurpose the talent. I have services I could sell here in the US or in Europe, but I don't have the human capital necessary to create it, and maybe the human capital doesn't exist anywhere, and we need to create it, right? So I think as we go toward more automation, we'll be able to create that human capital, and we can then manipulate it or distribute it in order to solve the world's problems. So I think in that regard, and I'll end with this thought, right? The architecture for success in the civilization is we start with cheap / free computer technology and sensing technology, which just creates the world awash of data. And then we augment that with cheap, free digital education, create software digital software that will provide education, right? Automate that, the education machine. Once we've done that, if we've got an education software apparatus that can be made freely available or cheaply available, the next element is free and precise digital certifications of capability. And that's what's been missing, right? I mean, we produce all these people, but our certification is very imprecise. Everybody from MIT has the same degree in aeronautics, and yet they don't all have the same skills in aeronautics. Some are really good at some things, some are not good at some things. So it used to be this idea of, I'm just going to give you, there are business schools that they have this presumption that, well, we're not going to give grades, okay? We're too good for that, right? If you went to whatever, Stanford Business School, you ought to just accept the Stanford brand and let us do anything we want with any of your money. And I tell you the problem with that. I have found that there's a theme, and the theme is business school grads that have training in product management or training in project development, all these things, they're all failing at a massive rate in the real world because that person at Google wants the car to drive via LiDAR. They don't want like a theoretical plan. If you don't know what LiDAR is, you're going to fail no matter how good your B school degree is. We don't need general skills and general problem solving. What we need is someone that knows that Amazon hasn't deployed its full stack of services in Beijing, and so your product will absolutely crash and burn in Beijing until they do that. There are very particular things that we have to do. And if you're going to actually solve these problems in the real world, you have to have technique. And the technique means, well, do you or don't you have enough mathematics to solve this problem? If you haven't mastered the calculus of variations, you will never solve this problem. It doesn't matter whether you have a prestigious degree. I don't care if you have 4 PhDs from the best school on earth. I need to know whether you've mastered the calculus of variations. We need that very precise, and by the way, I'm using examples that have been around for a long time, right? Isaac Newton gave us a calculus of variations. You want to solve some problems in the tech world, there's stuff that Amazon invented last year, they're putting into the market this month. And if you don't master that particular technology, you will absolutely fail. Right? So it's a very rapidly expanding universe. It's getting more complicated at a rapid rate. And what we want is we want to very precisely know what someone can do. Not what they could do 20 years ago. I want to know what they can do now. And here's the issue. I don't have 8 hours to talk to you. And I don't have 6 months to find out, right? I can't afford to take 6 months to try it out. I actually need to scan 937 people in 1 second and find the one person that actually can really do that. Then I'll spend the next 6 hours figuring out what you need to be happy in the organization and help you transition and negotiate with you. But but I need to find the human capital, and we need to create the human capital. So when I talk about certification, I mean, we need it precise in an area, and in our case, like, we rate everybody 0 to 100. There's a big difference between, do you want the doctor that was 99 or 100, or do you want the doctor that was 50 on the scale of solving the problem that's about to kill you? I mean, you really want the best, right? Especially if I'm going to write a piece of software that does that thing 19 million times a minute. I really want the best. I don't want the average, right? I don't need the average. The world doesn't need 100,000 average algebra teachers. The world needs one really, really good algebra teacher then to be automated and manifested in software, which then delivers an algebra education to the next 10 billion people. We just need the best. Nobody wants the average phone, right? The iPhone that you have in your pocket is better than every device ever created in the history of man. Nobody wants the average one. They don't want the best. They want the extreme, and they want to stamp out 1 million copies of it. And that gets problematic, again, as the world's products get so diversified. So, I mean, the first step is cheap and free digital education. The second is precise certification, and ideally free, precise certifications. That should result in a massive increase in human capabilities. Give that to 8 billion people, and we ought to be able to double, triple, quadruple the amount of talent, or the amount of capability out there. And that creates an acceleration in the rate of human capital allocation, right? If we could precisely describe what those billion people could do, then we can move them between companies and employers. They can move faster, they can change jobs, they can redeploy themselves, and that's agile. And that'll create a massive output in goods and services. Everything that we might want, we'll produce more of it, and that creates an increase in productivity as a second order effect. As we find the most talented, and then we replace the crappy program with the better program, with the better program, with the better chip. And that, of course, is going to increase everybody's quality of life. And that will result in a general advance in human knowledge. And if you sum it all up, right, I mean, that's the formula for making the world a better place. And there are other things people are doing to make the world a better place, but I mean, I think we all share an enthusiasm for open education, and I see that dynamic of cheap education to more human capital, to more precision, to more agility, to more engagement. I see that as our best route in the 21st century to make the world a better place. And I know we can't do it alone. We need to harness the power of every organization, for-profit, non-profit, and governmental, we possibly can. But I want to thank everybody for being engaged in the process, and let you know I do appreciate, your support, and anything that we can do to help, we will. Thank you.